Welcome to the session on challenges in the use of AI in sewer management. We are joined today by Felix Naser, Head of Operations at Pallon.
I hope you had already a good and interesting day here at the online conference Blue Planet. And today, in this breakout session, we wanted to share a few insights around what we do with Pallon and computer vision, artificial intelligence around sewer condition assessment. Just to manage expectations a little bit, of course, we want to give you a little bit of understanding what we do, but we can, of course, not undisclose our secret sauce in a sense that, of course, there's a competitive advantage here we need to protect just to manage expectations. And the other thing I also wanted to mention, I'm with Pallon since 3 months, so maybe I will not be able to answer all of your questions, and please excuse that as well. So now a few words about the structure. So before we go into the details of computer vision and AI, I will share a little bit about the background and the setting in which we operate and aim to create value for our customers. And then in the second part, I brought a few examples and areas where we advance the system with computer vision and AI algorithms. And then in the end, I will close with a few case studies and examples how we already generate value for our customers. Yes, so as said, let's start with a little bit of a background. As you know, sewer systems are aging, and of course, this is then also increasing the need for rehabilitation, and very obviously, then sewers also need to be inspected, and currently this is done with remote controlled robots, and most of them are currently used with have a camera attached to them in one way or the other, and then a manual operator then is reviewing the footage that is coming from the operator. And as you can imagine, and as you know, this is a very tedious manual labor, and it's not only a lot of work, but also the people who can do this job, the specialists who are able to conduct these classifications and defect codings are very rare, and that's why we thought, okay, there's a big opportunity here to come in with computer vision and machine learning to automate elements of this process. Yes, so that's kind of the background and the setting in which we operate. And now I brought a few examples with me how we use computer vision and then also AI to help this process here. And so I first brought an example here where we use pose estimation to increase image quality. So on the left, this is coming from a 3D scanner. So on the left, you see the original image, and on the right, you see ours, which is a lot less distorted because we also use pose estimation to increase the quality of the image. And then the second example I brought here is where you see on the left, you see that the lens was dirty, and on the right, you see what we were able to do with basically smart stitching of images, using images where the water drop of the camera is not being seen. And the last example around more advanced computer vision algorithms is where we use camera pose estimation to generate a 3D reconstruction of the pipe. And this, of course, can then also be used for measurements and many more elements. Yeah, so these were a few examples I wanted to share around where classical computer vision algorithms are used. And now I will share a little bit about how we use deep learning, machine learning, or AI in our services. And here you can see this is actually a screenshot from our app, from our web app, where you can then upload your footage, and we then process it for you. And I will also talk a little bit more about the process steps later on. But here, just to walk you through this real quick. So on the top, you see what you might even call a street view for sewers. So you can move the camera left, right, up, down, back and forth, zoom in, zoom out, and basically move within this 3D reconstruction of the pipe. Of course, this is only possible if the footage has been provided from a 3D scanner. And then on the bottom, you see the 2D view that we've also seen before, where you also see that we've added here the defects. So you see joints, you see fissures, settled deposits, and so on. And now, sorry, there was a ringing on the bell. And now moving on a little bit here, of course, this is much more complicated than it might look like from a first glimpse, because we not only have to detect that here we see a connection, but we also need to take into account all the subclasses. So here in this case, it's a defective connection. It's also damaged, sorry. It's also damaged, and it's also intruding. And of course, these subclasses and measurements are not the only thing that make this hard, but also there's multiple points of view. So here you can see that this connection can be seen from multiple points of view in our app. And from all of these views, we have to give the correct estimate of the defect location and also predict it accurately. And then, of course, another challenge is that there are long defects that wrap and are continuous throughout the whole pipe. So we also have to find solutions how to display that correctly, and also how to annotate this correctly. And then, if you are familiar with sewers, of course, there's many interesting things you also need to be aware of. So, for example, there can be microcontrollers, and there's some mice running around, and maybe a credit card or other things. So very interesting anomalies we have to deal with, and these are just a few examples we selected here. And yes, just to closing up this section around challenges we are facing, of course, in every challenge is also an opportunity. And we are very excited about this, and because, of course, there's lots of training data in comparison to other computer vision and deep learning fields of industry applications. We have lots of data comparably. It's very interesting to deploy these solutions in this space because also we don't need to worry so much about timing. If it's not like an autonomous vehicle where we have to immediately react in milliseconds, but we can actually, in a matter of days here, redeploy solutions. And of course, exactly, we can also review uncertain cases again. So if we detect that our deep learning predictions are not as certain, we can redeploy a human quality check if needed, and then ensure highest quality for our customers. Yes, so now moving away from the examples and challenges, moving on to how this solution and service then plugs into the existing processes. So here you can see the process before you plug in Pallon services, and then after. So of course, as you know, before there has to be a visual inspection, and most of the time, even on site, the defect coding and classification happens. Based on that, then the condition assessment, planning, rehabilitation. And now with Pallon, what we can do for you is that you can increase your visual inspection capacity because you don't need to do the defect coding on site anymore. So with one team and one truck, you can do much more meters per day than before. And also the condition assessment can be done a lot faster because the higher quality and faster delivery times here. Yes, so now backing this up with a few case studies. So I brought two case studies with me here. One from Hansewasser Bremen, where this is a city in Germany with a sewer network length of 2,300 kilometers, and of course they need to comply with the self-monitoring guidelines, and that's why they are constantly deploying 5 inspection vehicles. And as we have also talked about it in the beginning, during the background setting here, this is of course a very manual, time-consuming process. And now with Pallon, they were able to do. Last year we did a project for 60 kilometers. We analyzed it, and of course, then since the coding didn't have to be done on site, we could increase the inspection performance by up to 26%, which is a really amazing result. And of course, the quality also became much more consistent regardless of the individual inspector, because it's always objective, fast, and consistent. And the second case study I brought with me is from Strabag. They do up to 1,000 kilometers annually. And again, a very similar problem here, where high effort and long waiting times of the manual defect coding is a problem for 3D scan footage. And now with Pallon, we did 160 kilometers last year. And we not only delivered consistently high quality, but also were able to reduce the waiting time from months to 1 week. Yes, and here are a few more words about from our customers. Of course, they like the precision in budget planning. It's a good foundation for the following processes. We also aim to keep our web app interface, very simple and easy to use. And of course, accuracy is very important. So to quickly summarize it, we want to be accurate, fast, and easy. And yes, quick words about our team. So we have, of course, we try to combine environmental engineers with computer and computer vision data scientists from leading universities, and that's basically already it. So if you want to know what we can do for you, feel free to check our services. And this was actually already it. So you can now feel free to ask questions, or we are open for an open discussion now.
Hi, this is Lucas from KWB. The model is being retrained every time it's used. Like you showed a few cases where it was implemented. So was the model retrained in these cases, or was the training set always the first?
Of course, I mean, what I can say is that the more data the model, the more data we have, the better the predictions get. So over time, of course, our services is always improving.
Thank you. And thanks for the presentation. It was very good.
Yeah, sure. Channel?
Thank you very much for the presentation. I have a question about how many defects can you detect today within the pipes?
We did of course detect all types of defects and also quantify the defects, and then we can also provide filter functions to allow the hiding of damages that are of a minor relevance. So if you use our service, you will get a complete so all defects will be detected and also quantified.
Okay, thank you.
Hello, Felix. Sorry, I had a problem with my mic. Can you hear me now?
Yes.
Yeah, I wanted to find out one of the key reasons why, like, a company will want to deploy AI to sewer management will be to see how it affects energy efficiency. So, is there any way of drawing on advantages in terms of energy efficiency from deploying this technology?
So this would be, I hope this would have been answered by for example, by the case studies we provided. So of course, since now the manual coding on site doesn't need to be done anymore because we automate the complete defect coding process, we can increase the performance a lot. And with this case study here from Hansewasser Bremen, we could increase it by 26%.
Okay.
Just by saving the time on site.
Okay.
So with the same amount of vehicles, more meters could be done.
Okay. All right. Thank you.
And of course, the condition assessment is also faster because delivery times are quicker. But maybe I can expand a little bit on that. So of course, the cost savings here in condition recording and assessment are given for sewer network operators, and they get, of course, the cost savings I just explained. They also get higher data quality and database rehabilitation planning. Engineering consultants, they get accurate and reliable defect detections, and of course, then they can focus on action planning, and they don't need to work on quality control, so they can improve their margin and work faster. And also inspection companies, they can use hardware and their staff more efficiently because they don't need to do the on-site coding. So we saw numbers up to 30% more per day And of course, they also get a consistent quality for their customers. Because it's not dependent on the individual inspector, but it's always the same objective, fast, and high quality data annotation they get. Thanks, and talk to you soon.